This is Geometry, Unit 2, Lesson 5 on Addition and Subtraction Postulates. The addition and subtraction postulates that we're going to be using is dealing with adding and subtracting segments and angles. So let's take a look at how it applies for each one. Let's look at the addition postulate first. The addition postulate says equal quantities may be added to both sides of an equation. Now that's true, we did that in algebra. Whatever you did to one side of the equation, you have to do to the other. So when you add two equations, you should get a new equation. And you always line up the equal signs and add vertically. So if we have a equals b and x equals y, and I set it up vertically, a equals b, x equals y, and I add them together, this side of the equation is a plus x, and then we have the equal sign, and this side of the equation is b plus y. So when you add one side of the equation, add the other side of the equation. So a plus x is equal to b plus y. Now, again, you have to make sure that you're making sense when you're dealing with line segments. Remember that, what you read in your homework about how to add segments together? For addition of line segments to make sense, the points must be collinear, all in the same line. What you're adding must share an endpoint. And the segments that you're adding must not overlap. You can't have half a segment added to another segment. It doesn't work. So if I have AB plus BC, these 3 points are collinear. B is the common endpoint between AB and BC, and they don't overlap. So what do I end up with when I take this segment, add this segment to it? I get the bigger segment, AC. Now let's actually apply the addition postulate to adding segments. So our given information is the stuff that we know about our diagram. We are given that ADB is a segment and AEC is a segment. That tells me those points are collinear on that segment. That's where everything falls. I'm also given that segment AD is congruent to segment AE, so I'm marking it here. And segment DB and EC are also congruent. Now those two are congruent, but they're not the same as the other two, so I'm just going to make them different hatch marks here. Okay, now if I add these segments together, if I set them up vertically, I have AD is congruent to AE, and I have DB is congruent to EC. If I add those segments together, AD plus DB, and then add AE plus EC, what do I end up with? Well, plus EC, sorry. I end up with a new segment. AD plus DB gives me this whole segment, AB. And then AE plus EC gives me this whole segment, AC, and those two segments are congruent because I took two equal quantities, I added two more equal quantities to it, and I got a larger segment. So equals added to equals give you equals. So we can say by the addition postulate that AB is congruent to AC if we are given these two segments. So if you have smaller segments and you want to make them larger segments, you have to add them. You line up the equal signs and then add each side and make sure they're equal. All right, let's try this one. AB, AC, and FED are segments. ABC, FED. That means all those points are collinear. We have AB is congruent to ED, and BC is congruent to FE. Now, based on the addition postulate, what segments can I say is congruent? Well, let's add them together and see. AB is congruent to ED. We have BC is congruent to FE. Added together, if I take AB plus BC, what do I get? Well, I actually get AC. And that's going to be congruent to, if I take ED and add it to FE, I end up with DF. So equals added to equals, I end up with these two segments, AC and DF are congruent. Now let's see how addition applies to angles. Now remember, for addition of angles to make sense, the angles must be adjacent and they must be non-overlapping. They must be next to each other, but they can't overlap at all. So let's take a look at the angles that we have for this problem that we know are equal. AFB, which is this angle right here, is congruent to DCE, this angle right there. Those two angles are congruent. Now we also have that BFE this angle here, I'm putting different hatch marks on there, or different arcs on there so I can tell that they're different angles, is congruent to ECB. ECB, which is this angle right here. When I take those two angles, you can see that they are adjacent to each other. This one's next to this one, and this one's next to this one, and they don't overlap. They're two separate angles that are next to each other. But if I add them together, angle AFB is congruent to angle DCE, and angle BFE is congruent to angle ECB. What do I end up with? If I add these two together, I end up with this bigger angle here. Now, the name of that angle would be, using these values, AFE. AFE, or you can say AFD is fine. Angle AFE. And that is congruent to DCE plus ECB added together makes this bigger angle here, and that angle is DCB. So I added two smaller angles to make a bigger angle. All right, let's try a little challenge. We have angle YDM, which is here, is congruent to angle NDO, NDO. Those two angles right there are congruent. But I want to prove that angle YDO, which is this angle right here, is congruent to NDM, which is this angle right here. Oh, now I want to be able to add because I've got a bigger angle, but I don't have anything to add to this or this that's stated. But what am I actually adding to YDM and NDO? Well, let's take a look. We know that YDM is congruent to NDO. That's given. That says so right there. Now, if I want this angle right here, I'm missing this part right here. What angle is that? That's angle MDO. That's angle MDO right there. All right, now if I look over here at this angle, I want this angle here. I'm also missing MDO. Oh, what property did I just show right here? What property is this? Well, that's the reflexive property. Remember I said the quantity is always equal to itself will come into play? It does. This is by reflexive. We can say MDO is congruent to MDO. So now we have two equal quantities to add to both sides of the equation. So YDM plus MDO gives me the angle YDO. And that is congruent to angle NDO plus MDO, which is angle NDM. So if you need something to add, see if you're actually adding the same piece to both sides of the equation. If it is, you have to apply the reflexive property for that to work. Now the subtraction property. Basically it works the same way as the addition property except that you're using subtraction. It says that equal quantities may be subtracted from both sides of an equation. So you always subtract two equations to get a new equation and always line up the equal signs and subtract vertically. So if we have A equals B and X equals Y and we want to subtract them, we have to go A minus X is equal to B minus Y. So we write them in order. So A minus X is equal to B minus Y. Now the same thing with subtraction of line segments. There's some ways that have to happen to make sense. When you subtract line segments, they must be collinear. They must all be on the same line. They must share an endpoint. You have to be able to, if you're going to take off a part of it, you have to know what part you're taking, and they can't overlap. You can't take a piece of something out of the middle. So, for example, if I took AC and I subtracted off AB, what am I left with? I'm left with BC. Or, if I take AC and I subtract off BC, what am I left with? I'm left with segment AB. So notice all of these, they're collinear, they have the same endpoint, and they don't overlap. So if you want to take a piece of a segment, it has to be a certain piece. You can't just take any random piece off a segment. You have to have a non-overlapping and collinear and sharing an endpoint. All right, so let's see if we can apply subtraction to these problems. Now, remember when you're subtracting, you are taking a part away, so you're actually going from a larger segment or angle to a smaller segment or angle. So I have ABCD, which tells me these points are collinear. They're all on the same line. And I have AC is congruent to BD. So there we have AC is congruent to BD. Now, I want to make two smaller segments that are congruent. Now, notice those segments, if I want to make them smaller, what part do they have in common? That if we take it off, it'll be the part that we want. Well, let's see. Let me draw them out separately here. I have ABC is my one segment with B in the middle. Here's A, B, and C. And then I have my other segment, BD, that has C in the middle. Here's B, here's C, and here's D. Okay, so we know those are equal. Well, what do these two segments have in common? Well, don't they have piece BC right there in common? Yeah, they do. So if we take AC congruent to BD, and then use the reflexive property, BC is congruent to BC, because that's actually the same segment by reflexive, I can now say, by subtraction, AC minus BC is congruent to BD minus BC. Well, what is AC minus BC equal to? AC minus BC is equal to AB, and that is congruent to BD minus BC, which is left with CD. So you can see subtraction works as well. You just have to make sure that you have two things to subtract. All right, let's look at this next one. We have segment NRT and NGL, where NT is congruent to NL, and RT is congruent to GL. So if I take those two congruent segments and subtract them, what segments am I going to end up with? Let's see. NT is congruent to NL. RT is congruent to GL. And if I cut them off, cut these pieces off, what am I left with? NT minus RT is NR. And NL minus GL is left with NG. Now let's see how this works with angles. For subtraction of angles to make sense, the angles must share ray and overlap. So here's my two angles, or three angles technically, and they don't overlap, so let's see what we can look at for this. We have XOZ, and if we take off XOY, which is this angle right here, what angle are we left with? We're left with angle YOZ. And if I do this the other way, if I have XOZ, this angle here, XOZ, and I take off YOZ, by subtraction, what am I left with? I'm left with angle XOY. So there we go. So if we apply this to our next problem, let's look at our angles. Angle ABC, ABC, which is this big angle here, is congruent to angle ADC, ADC, which is this angle here. And then we also have the angle ABD, ABD, I'm going to mark the corner in like this, is congruent to angle CDB, CDB right there. If I subtract those two angles, what angle am I left with? Well, let's see. Let's line them up. ABC is congruent to ADC. And then I have angle ABD is congruent to angle CDB. Let's line them up and see. All right, so ABC and ABD, I am left with this angle right here. That is angle CBD. And if I have angle ADC and subtract out CDB, I'm left with this angle right here. And that's angle ADB. So when you subtract angles, you go from a bigger angle to a smaller angle. If you're subtracting segments, you go from bigger segment to a smaller segment. Okay, we have one more. Now let's look at the last one. We have angle QPS is congruent to angle TPR. QPS is congruent to TPR. Now again, if we're subtracting, we want to take out another piece that is equal in both of those. If you look at where these overlap, if you look right here, you can see that that angle right there is where they overlap. That is angle RPS. So we can use angle RPS as our reflexive to do that. So angle TPR and QPS congruent. If we take angle RPS away from both of them, we end up with these two angles. Angle QPR, which is congruent to angle TPS. So these two angles end up being congruent. and that is adding and subtracting segments and angles using the postulate.